This video we're looking at Module 2, Lessons 1, 2, and 3. And the easiest way to cover multiple lessons instead of just going over every single problem in the lesson is to go straight to the exit ticket, because that's going to give you the meat of the lesson, what the lesson's really talking about. So in Lesson 1, it's a really simple problem, or a really simple lesson. We were talking about it in class. If you stand up and then you sit down, you close your eyes and you open your eyes. You take 2 steps forwards and 2 steps back. All of those actions are opposites of each other. And what happens when you close your eyes and then open your eyes? You end up right back where you started. Just like when you take 2 steps forward and then 2 steps back, you end up exactly right back where you began. And that's what this lesson's about, is getting us to understand opposite actions, also called additive inverses. So in number 1, or reading the instructions, it says for problems 1 through 3, describe an opposite action and then write a true number sentence that appears in both actions. So if Sarah opens a window 10 inches, Sarah closes a window 10 inches. And a math problem that would show that if she opens the window, it opens a gap 10 inches wide. And then if she closes the window, that would be a negative 10. And 10 plus negative 10 gives us 0. And we can see that by using a number line. And this is called an imprecise number line, because I won't put any numbers or any other tick marks other than 0. And the way to show this on an imprecise number line is if we have a positive number, that means we're going to the right. So if I was going to the right 10 tick marks, this would represent my positive 10. And then while I'm over there at the 10, I end up coming back and closing that window, and that would show a negative 10. And where that second arrow ends is where my answer is, and we're at 0. So those two cancel each other out. So if Pedro gains 3 points, the opposite of that would be Pedro losing 3 points, or loses 3 points. And then the number sentence for that would be if he gains, that's a positive. But if he loses, that's a negative, and that gives you 0. And the number line would be going to the right 3 times and then coming back, going to the left 3 times and getting back to 0. And then if you give a friend $15, then the opposite of giving a friend $3 would be you get $15. So if you give a friend $15, you lost those 15. That would be a negative. But then when you get it back, it becomes a positive. And opposites or additive inverses cancel each other out and become 0. So in this one, you would go to the left 15 tick marks and then back to the right 15 tick marks. Problem number 2 is going to be precise number lines. Imprecise number lines, like we just looked at, don't have any numbers on the tick marks. It's just a simple 0. It kind of gives us an idea of where our arrows are. But on these, it's going to be precise. We're going to use these tick marks to help us solve the problem. Now, when we're doing this at the beginning, I don't want you to look at the numbers on the number line at all, because a very common mistake is for people to do the first number. So we got to have a negative 4 first. So a negative 4 means it's going to be a line that goes to the left 4 tick marks. So like this. And then once you're at the negative 4, a common mistake is for people to go right back to the 0. And then they say, oh, I'm going to show a 6. Oh, here we go. That's a 6. And that is incorrect, because we are not going back to 0. Once we go from 0 to negative 4, we are at negative 4. We then have to draw our line 6 tick marks. And another common mistake that people make is they start at negative 4, but then they go right back to the positive 6. Well, that line going to the right ain't 6 long. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 long. It's not what we're looking for here. We want that line to go, and I'm going to not do it with a straight line. We want it to go from negative 4 and go 6 tick marks. I'm just looking at the tick marks. 1, 2, 3, 4, 5, 6. So I'm stopping right here. That's 6 tick marks. And then I can look at the number. My answer to that problem is a positive 2. And then the one down at the bottom, again, using a precise number line, we're going to go ahead and go the negative 6 first. So we're going to the left. We're going 1, 2, 3, 4, 5, 6 tick marks. And then while we're there, we turn around and we keep going. Another negative 2. So 1 tick mark, 2 tick marks. Where does that line end at? It ends at the answer, negative 8. And that is using precise number line. So different strategies that we were using. In lesson 5, we use decomposition and additive inverses to help us solve problems. So here we have lesson 3, and it says Maya competes in a quiz show. Her answer to the first question is incorrect, and she loses 425 points. If you lose 425, that's going to be a negative. And then her answer to the second question is correct, and she earns 300 points. So that would give you 300. After the second question, is Maya's total score positive or negative? So now an easy way for us to figure that out is to use one of those imprecise number lines and really quickly come up with that answer. So we have our 0 here. If she went a negative 425, here's a negative 425. Obviously 300 would not be that big, so we would come back 300 to the right like this, and you can see that we are still on the negative side. So this answer would be negative. Then it says to write a numerical expression to represent this situation, so we can figure out what her score actually is right now. So that would be she lost 425 points, but then she gained 300 points. So negative 425 plus 300 is our expression. Expressions don't have an equal sign. But then for part C, it says, what is her score? And show your work. So that would be negative 425 plus 300. And we could use any of our strategies that we know so far. Imprecise number line, precise number line. In lesson 5, we looked at lesson 5 already when I made this video. So in lesson 5, we could decompose these numbers and make that negative 425 be a negative 300 and a negative 125, and then the 300s would cancel each other out. Or we could use our integer rules, which takes us to this, where we're going to actually write down those integer rules. So the integer rules are separate if you have the same sign or if you have opposite signs. So when I say same signs, I mean that you have a positive plus a positive, or a negative plus a negative. And what those imprecise number lines would look like for a positive and a positive, we'd have our 0 here, and then you would go to the right some positive number, and then you would continue going to the right with that next positive number. For the negatives, you would be going to the negative and then continue going to the left with that other negative. So if we had a problem like that, it would be something like this first one. If we had two positives, 5 plus 3. So you would go to the right 5 times, go to the right 3 more times. When you put those numbers together, you get an 8. So here's what the rule says for positive numbers. Positive numbers say that you should add the absolute values and then the answer it keeps the sign of the two numbers being added. So to see what that looks like, let's take a look at this negative number. If we've got a -5 plus a -3, those are the same signs. And just like you can see on our number line, if we go to the left 5 times and then to the left 3 more times, if we have the same number, absolute value of -5 is 5, absolute value of -3 is 3, and we add those two numbers together and we get an 8, both of these numbers are negative, so our answer is negative. So those are our integer rules for problems or addition problems, because everything's different: addition, subtraction, multiplication, division. So addition has the same signs. You add the two absolute values together, and the sign of the answer is whatever the sign of the two numbers in the problem are. Looking at the integer rules for opposite signs now, this could be a positive number plus a negative number, or it could be a flip of that. The negative number comes first and then a positive number. Now with these, our number lines could look quite different. So on the first one, we could have a number that is positive, and then a larger absolute value number be negative, which would take us across the 0. Or we could have a larger positive number and then a smaller negative number that isn't big enough to get us across 0. And then the same is true with the negative number becoming first. We can have two different situations here. Again, if we go negative first with a smaller absolute value, and then a positive number that takes us across 0, or we can have a larger negative number first with a smaller positive number that keeps us on the negative side. So the rule for this one, for opposite signs in addition, is that you subtract the absolute values of your numbers, your two numbers, and then the answer keeps the sign of the number with the largest absolute value. So let's see what that type of model looks like. I'm going to go ahead and number these number lines here. So number line 1, 2, 3, and 4. So looking at number 1, we would have a smaller positive number first. So here's number 1. If we had a smaller positive number like a 3 plus a larger negative number like -5, we would take the absolute value of 3, which is 3, the absolute value of -5, which is 5, subtract those two numbers. 5 minus 3 is 2. And the number that has the largest absolute value is at -5. It's negative, so our answer is also negative. Looking at number line for 2, we have a larger positive number. Let's say that positive number is 8. And then a smaller negative number, let's say -2. We would have opposite signs, so we take those two absolute values, 8 and 2, subtract and get 6. The larger number is the 8, or the larger absolute value is the 8, so then the answer 6 stays positive. And as you can see on our imprecise number lines, we stay on the positive side for this one. And on number 1, we crossed over and went to the negative side. So you can see that those absolute values, those distances from 0, really do determine exactly where we are on the number line. For the third number line, we have our negative numbers first, and it's a smaller negative number. So let's go with -3 plus a larger positive number. Let's go with 6. Again, we have opposite signs, so we subtract absolute values. 6 minus 3 is 3. The larger absolute value is the 6, so this answer stays the 6. As you can see on the number line, it stays positive. And then the last one, number 4, we have our larger negative number first, and then our smaller positive number. We subtract those two. 6 minus 3 is going to be 3. 6 is larger, it's negative, so the answer is also negative. And those are our integer rules. So let's go back and look and see how we can use that to answer problem, the exit ticket on lesson 3, which is this problem right here. So looking at it, there's two opposite numbers, which means I subtract. So 425 minus 300. It's going to give me a 5, a 2, and a 1. So the answer is going to be 125, but I have to remember to go back and look which one has the bigger absolute value. 425 is the bigger absolute value. It's negative, so my answer is negative. And then the other method that we learned in lesson 5 is being able to take a problem like this and do the additive inverse like we did in lesson 1. Find the opposite and be able to make it into 0. So we would decompose 425. It would be a negative 300. That would go against this positive 300. And if I took 300 away from 425, that would leave me with a negative 125. It's negative 300 plus negative 125 gives me negative 425. And then those two opposite numbers, negative 300 and 300, would go away, leaving me with my only answer left, negative 125.